Hello class, welcome to the next lecture on control systems. So today what we will be doing is we will be seeing some examples on how to do block diagram reductions. In the last lecture we had gone through different techniques, that is the three basic ones, that is cascading of blocks, then there was parallel blocks, how to reduce these, and then there was the feedback, right, how we would reduce these three setup, right. Then we considered how to change the blocks when you are interchanging, summing and takeoff points and things like that. So today what we will be doing is we will be solving some small problems so that you get an idea how to approach them. Okay. So we'll start off with one question. So what I'll be doing is I'll be giving you the idea rather than completely solving the problem. I'll just draw the original block diagram. I'll show you how to reduce them, and then I'll just write down the final answer. The other things, calculations, you will have to do. Okay. So the question is find overall transfer function. Okay. We have a plus here, we have a plus here, we have a plus here, and this is your output C of S, this is your input R of S. Okay, and then there is a feedback from here, which is given as H2. It is a negative feedback. Then you have another feedback here. Which comes here. Okay. This is plus, this is minus. So here actually you don't have much to do. All you have to do is you have to combine this and you have to combine this, and finally you can cascade these three and take the feedback of this cascaded thing. So how will the new one look? The new one will be, after reducing these two, it will be, you will have your G1 here, right, then your G2 by 1 plus H2 G2 here, and then you have your G3 plus G4 plus 1 here, right, and you have your feedback here. So now this, how do you find the overall transfer function? So this you can replace with one complete block, right? This thing, this cascade can be replaced with one box which will have a transfer function. What will be the transfer function of this new block? It will be G1 G2 into G3 plus G4 plus 1, the whole divided by 1 plus G2 H2, and that will be fed back with this H1, and now you have to find the overall transfer function for this particular one. How do you do that? That is, you have the transfer function, overall transfer function is equal to g1 g2 into g4 plus g3 plus 1 divided by 1 plus g2h2 whole divided by 1 plus g1 g2 g4 plus g3 plus 1 into h1 divided by 1 plus g2 h2, which will be equal to this will come here and the denominators will get cancelled. G1 G2 G4 plus G3 plus 1 whole divided by 1 plus G2 H2 plus G1 G2 H1 into G4 plus G3 plus 1. This will be your final answer. Okay, so this is how you do a simple block diagram reduction. Okay, now that I have shown how to do the reduction and the cascading and feedback and things like that, now I won't explain how to reduce certain blocks. I will just show you which blocks to reduce and how to split them or things like that. Okay, so this is our new question. The question is again find the overall transfer function. So what is actually here also it is very similar to the last problem, because you don't have any complicated shifting of points, right? All you have to do is split these things into whatever you need, right? Right away you can identify certain blocks, like you have a feedback here, right? A feedback here, then that will get cascaded with this G2, then that will get that whole thing will be fed back with H2. So before that, what you have to do is you have to split this summing point, like that is just for the primary stage, because you are getting used to. So I'll just show how you split it, right? So you can split it into 4 blocks, so 4 summing points. So in when you are going ahead and doing more problems, you don't have to split this. I'm just showing this so that we are starting off with this, and you will have a better idea how to visualize this kind of problems. So we have our first block, right? It's like feedback within a feedback, like that. And finally the last feedback. Okay, so this is R of S and this is a C of S. Now it is pretty much simple, right? Because this is a first loop, right? So you can replace this with G1 by, okay, let me just redraw it here itself. So this one will become what? This will become G1 by, it will become a new block, that is G1 by 1 plus G1 H1, right? G1 by 1 plus G1 H1, right? That gets cascaded with this G2. So it will be G1 into G2. So let me write it here and erase this G2 here. Okay, so that is gone. So you only have this one. So now this path, this block and this block will be in a feedback loop. So the effective transfer function of this much, that is this much, this will be changed. What will it be? Let me just redraw that. Right. So you can replace this with one block. What will it be? It will be G1 G2 divided by 1 plus G1 H1 minus, because it was a positive feedback here, right, minus G1 G2 H2. Okay, now what do you have to do? You have to cascade it with this one. So G3 will come here, and we can remove this G3. So when you're writing your exam, please do it step by step. Okay, now what do you have here? You have this one with a feedback here. So you have to replace this whole block, right? Then you have to cascade it with this one. Then you have to feedback with this whole thing. So finally, your answer will be transfer function G1, G2, G3, G4 divided by 1 plus G1 H1 minus G1 G2 H2 plus G1 G2 G3 H3 plus G1 G2 G3 G4. Okay, this will be a final answer. Okay, so this is the next question. The question is to draw the equivalent block diagram. Equivalent after what? After shifting this summing point to here. Okay, we have to see what all changes we have to make. Okay, you don't have to find the transfer function for this one, you just have to shift it. So if you're shifting this one, okay, let's right away draw it. What will the changes be? Okay, let's see. You have your G2 here, like I mentioned in the previous class. Shifting point will come here, like I mentioned in the previous class. The shifting shouldn't affect the main path. Okay, so this will come here. This particular block, I am putting it in red to denote that it is new. And in this one, sorry, will come here. Okay, plus minus. Okay, let that be, that is not of significance right now. Okay, so coming to this one, both of these blocks are initially being summed here. Okay, and whatever effect it has, the path was like this, right, and for this the path was like this. So at this point there is no interaction between the signal A and G2. Also there is no interaction between the signal C and G2. But when it comes here, the signal A, B, see, okay, the signal A has to go through G2 and the signal C has to go through G2. So that is what initially what will it be, the output? It will be A into G3 into G4, and this one will be C into G3 into G4, C into H into G3 into G4 in the main path I am saying. But now it will be what? This G2 is getting added, right? So you have to counteract for this using whatever block is coming here. Okay, so A into here obviously G5 is there, here h is there. So how do you counteract for this? You divide whatever is here, this block, with G2. So this one will be G5 by G2 and this one will be H by G2. So you have seen this, how to change. So this is how you change the blocks in the branches, not the main path, the branches, depending on what the shift is. Okay, here because we are adding a new block into the path of this shifted blocks, you have to cancel for that. If you are shifting this forward, you would have to multiply it with G3 because you would have missed G3 which was there in the initial path. So this is how you shift. Okay, now let's see a problem on how to calculate the complete transfer function. Okay, so this is the next question. The question is find the transfer function Cs by Rs. So in this one they have not told you which block to change or which point to change. Usually they won't. So they'll just give you the block diagram and ask you to reduce it. So it is up to you to identify which block to change, right? So right away, let's say you can identify a feedback here. You don't have to do anything, you can implement it directly. Also, there is a feedback here. There is a parallel path here, right? There is a parallel path here and there is a feedback here and there is a feedback for the whole thing. So here there is no conflict, you can directly implement it. But for these two there is a conflict because this forward path is coming in between the feedback of this one. So change whatever you are doing, you have to change it somewhere here, right? So what will you do? You can either shift this point here or you can shift this point here. So I am choosing the first method. I am choosing this point here, so you will get a feedback between these two and you will get a parallel between these two. Okay, let me redraw it. Right. Your G1 will come here, the summing point, so there is no changes here. Okay, here G2 and I have shifted this point to here. So you will have a changed feedback here. I am drawing it in red so that it is visible, right? So will this summing will this block have any change? No, right? Because you are just shifting this one, you are not changing here. So only the changed blocks will have any difference. So your plus, plus, then you have your feedback here. You can split this. Okay, let's, for the sake of convenience, for this question, let's split it. You don't have to because you can identify G4 and H. And finally, you have a feedback. Okay, let me split that too. Okay, so this is your C of S, this is your R of S. So we have removed all the conflicts from this. So what do you have? You have your one feedback here. Okay, let's call it number 1. You have your parallel block here. Let's call it number 2. You have your feedback here. Let's call it number 3. Okay, then have your cascade here. Number 4, and finally you have your last feedback here. Let's call it number 5. So this is how you solve it. But now, what is the change here? If you have taking this here, how will it change? Will it be just H2 or will there be any change? Okay, so let's see the initial path was like this, right? This was the initial path. So it was G2, G3, H2. But now it is only G2 and whatever is coming here. That should be equal to G2, G3, H2. So this should be what? H2, G3. Okay, then only the signal values will be staying the staying the same. Okay. So this is from here you can do. Okay. I think the final value is transfer function is equal to G1, G2 into G3 plus G5 into G4 divided by 1 plus G2, H2, G3 into 1 plus G4, H1 plus G1, G2, G3 plus G5 into G4. This is the final answer. Okay, now moving on to the next question. Okay, so the question is to find the transfer function of this block diagram. So again I'll just draw the change only. Okay, so what is happening here? We have a feedback, right? So that actually we can isolate on its own. That is not a problem. So here we have a parallel setup and here we have a feedback for the whole thing. So we need to arrange between this feedback and this parallel system, right? So either we have to shift this summing point of this particular block from here to beyond this summing point, or you will have to shift this to here, this takeoff point to after this summing point. So I'm going to stick with the first thing. I'm going to shift this summing point here. Okay, so let's see how that turns out. That is, we have our summing point here and I'm shifting this one to here, this area. So it will be, I'm using red for this one. Okay, it is added, so it is plus. Then we have our G1 here, the summing point for our feedback. There is no change here at all, nothing is changing here. H2 minus, then your other feedback which comes here. Okay, so it will be H1. So here we have CS and here we have RS. So what will be the value here? What will it be? Here when you are considering the signal here, what is coming here is RS into GS, right? RS into, sorry, G3. Okay, RS into G3 is coming here. But here, whatever is coming here, it will be RS into something X into G1, right? Because the path is like, here the path is this one, here the path is this one. So whatever is coming here will be multiplied by G1. These two should be equal, right? So we can write what this one we have to this cancel for this G1. So this will be G3 by G1. That is how you get it. Now it is pretty straightforward, in the sense you have a parallel branch here, you have a feedback here, you can find the feedback, multiply it with this cascade, then get the feedback of this whole thing, then multiply it with this parallel thing. So the final answer, the final transfer function, it will be what? G3 by G1 plus 1 into G1 G2 by 1 plus G2 H2 plus G1 G2 H1. This will be the final answer. Okay. So I will be giving some homeworks in the material lecture notes I am providing. I have marked it as homework, so please go through them. Okay, I am just giving some sample questions here. So most of the work and most of the hard ones actually I am giving as homework. Okay, now let's see another type of question. Okay, so the question is to find the transfer function for both cases. That is, here we are giving two inputs, station 1 and station 2. So the question is to find the transfer function for when station 1 is the input and for when station 2 is the input. So what do you do? When station 1 is the input, you make station 2 as 0. So you just simply ignore this summing point and you calculate the transfer function. If station 1 is 0, what do you do? Or when you want to find the transfer function for station 2, you make this as 0. So therefore there are no other points. You just ignore this summing point and you connect this. Okay, so we'll do that. Okay, so let's write for station 1. Okay, only considering station 1. So this will be our R of S. Okay, that is here, this one. From that it is going to G1, right? So when you are considering station 1, here we have this problem, right? This feedback and this feedback are sort of mixing together. So we have to accommodate for that. So what I will be doing is I will be shifting this one over to here. Okay, so that this feedback will be within this one and there won't be any conflicts. Okay, then we have our summing point here. Okay, we are shifting only the takeoff point for the feedback. We are not shifting the summing point. So we have G2 here, right? Then we have a summing point for this feedback, G3. From there we have takeoff point and this okay, let this be minus, and this one is the one that we are changing, which I am showing in red. Okay, and I am moving it to here, and finally we have our last summing point, which comes here. And we have our H1. Okay, so when we are moving it to here, this summing point, when you are moving the summing point when you are moving to here, what is happening? Earlier the loop was like this. Okay, so it was G2 H3. Now the loop is like this, that is G2 G3 and whatever is coming here is there. So that you have to make it equal to, that is G2 H3 should be equal to G2 let's say X G3, right? G2 X G3, these should be equal. So whatever H will be, what will H be? It will be H3 by G3, right? So that let's rewrite it. This will be H3 by G3. Okay, so now we have that, and we have a C of S. Now it is straightforward, like whatever you have done now. You have a feedback here, you have a cascade here, you have a feedback for this whole thing, right? then you have a cascade here, then you have feedback for the whole thing. Okay, and finally the transfer function, I'll write the final answer. Transfer function will be g1 g2 g3 divided by 1 plus g3 h2 plus g2 h3 plus h1 g1 g2 g3. This is the final transfer function for when there is only station 1 as the input. So remember, similarly, when you're doing other multi-input, multi-output systems, when you're asked to find the transfer function for a particular input and a particular output, just make the other inputs 0, and if there are any outputs, ignore that particular output branch. Just continue with the remaining. That's all. Okay. So now let's see how we do station 2. How do we have to rewrite for station 2? So for station 2, this will be 0, right? This station will be non-existent. So what happens? We can simply connect this line, right? This one will be going like this. So this will be a cascade. And here only one, only this input will be here. Still, we'll be having the problem that we faced earlier. That is this particular feedback and this particular feedback, that will be conflicting. Okay, so what I am doing is I am, for this time, instead of shifting this h3, I am shifting h2 to this side. Okay, I am shifting h2 to here, so that there will be one feedback here and there will be another feedback here, so things will be normal. Okay, let's see how we can redraw it. So we have our station 2. So like here I have given RS as input, here also I am giving RS as input. So that is just for notation sake, no worries. G3, and we have our output C of S. Okay, and this side what is coming? We have our G2 and we have our feedback, which is H3, which is coming here. Okay, here okay, it is not a positive feedback, it is a negative feedback only, right? Then what do we have? We had in this particular problem we are shifting this feedback instead of this one, because earlier the input was here and there was no input here, so we could easily shift to here, but here this time the input is coming here, right? So we cannot move this one over to here. It is better if we move h2 to the left side, so that we have, okay, as usual let's just follow the notation. The ones which are having change I will draw in red, right? And similarly there will be a slight change in this particular box also. Okay, so, and we have our last G1, which is coming here. Since the summing point at that area is gone, is changing. Okay, so now what is the change? Here, okay, here the loop was H2 G3. Okay, now the loop is whatever is coming here into G2 into G3, that is G2 is additional and we have to compensate for G2. So what will we do? We will divide, so H2 by G2. This is similar to what we had done. And here what is the change? Actually we are not shifting anything, nothing is there, just H1 should come, right? It should be H1, right? No, the thing is here it is a negative feedback, right? Negative is here. So since the summing point is gone, we have to accommodate this minus somewhere. For that, what we do is we make this block as minus h1, right? So please don't make that mistake. Now you can take this feedback, right? You can consider this, make this into one block. You can take this like that. So finally, this is simplified, and the final answer will be G3 plus G2 G3 H3 divided by 1 plus G2 H3 plus G3 H2 plus G1 G2 G3 H1. So this is how you approach a multi-input, even for a multi-output system. What you have to do is just ignore the output that you are not considering. That is, you don't have to go through that path, because for example, right, if you have let's say G1 G2 G3, this is C1 of S, this is R of S. I am not drawing anything complicated, I just wanted to show a concept. G4 G5 and C2 of S. Okay, so when you are considering, okay, if you are considering this, suppose the transfer function you want to see is C2 of S by Rs, what you do is we only consider this path, because this path is irrelevant for us in this particular scenario, right? Because we don't want to know what signal is going there, it is irrelevant. What we want to know is what signal is flowing in this path, right? If there is any feedback, we have to consider that also. But whatever is, the thing is that the main path we are considering should be from the input to the output that we are considering, and not the thing that is going there. If suppose we had a connection like this, from here we had a connection like this, okay, summing is there, then what you have to do, we have to consider this one also. We can eliminate only this much, okay. And if in this particular case, if we are considering this C1 by R, then what do you have to do? You have to consider this particular path. Here you don't have to consider this one, because there is no feedback from here, right? There is no feedback from here, so there is no point in considering this path. If there was some feedback, suppose something like some signal was coming from here to here, okay, then you have to consider this much also, okay. Also, since there is a feedback from here to here, you may have to consider this also. That is the thing is that you should consider the signal from the input to the output. Is there any feedback? Only that much you have to consider, okay. So that is regarding multi-input, multi-output systems, and I have given some other questions to do as homework, okay. Now let's move on to another type of shifting or manipulations that you have to do, okay. Now let's move on to the last type of that is like last different type of problem that we have to see. Okay, the question is to find the transfer function of this particular block diagram by implementing this swap that is being shown here, okay. So let's redraw. First of all, there is no change in the main path, okay. right? CFS, RFS. Okay, and we have our feedback H here. Okay, now we want to put this here, right? So this forward path should start from here. Okay, now let's see what is happening here. Here the signal coming here goes like this and gets added here, right? Now if we are swapping it to start from here, okay, what is happening? The signal coming from here will go like this and gets added to or multiplied to G2 and goes like this. Okay, but here what is the difference? What is the difference? Here actually only RS is being multiplied with G2, but here what happens is RS, here it is RS, here it is CS into H, or whatever, let's call this F. Okay, whatever is coming here. So here at this point, what is there? R plus F is there. So here it will be G2 into R plus F. That is an extra signal. This F is being, sorry, not plus, sorry, minus, R minus. Okay, because it is a negative feedback. So that extra F is being coming, it is coming here. So we need to compensate for that. Okay, we need to remove this F. In earlier cases, when we were shifting this interchanging this summing and takeoff points, what was happening? We were dividing, right? Because that gain was being multiplied. But here, because we are interchanging this takeoff and summing point where a feedback is involved, in this particular case, actually we shouldn't divide or multiply, we should add, right? So let me redraw this particular image. Okay, so we have our, let me use red like the convention that are following, G2. Okay, the thing is that we have to compensate for this H which is being added. For that, what we do is we do something like this, right? We do something like this. Here H is being subtracted, minus, that is C into H, minus C into H is coming here. So here what we do, we put it as plus. Okay, so at this point, let's call this point 1 and point 2. So at point 1 it will be R plus C into H, sorry, R minus C into H, right? At point 2 it will be what? R minus CH plus CH. So it will cancel out, right? It will just cancel out. So it will be equal to whatever is coming here. But the thing is that this makes this particular thing makes the analysis more complex. So we need to remove this, right? We need to eliminate this particular summing point. So let's see how we can do that. Okay. So basically what is happening, what we are going to do is we are going to split this thing. So if you're taking here actually one path is going like this and another path is going like this, right? Two paths are there. So what we do is we'll make this as one path and we'll split this and give another path here. It's pretty much intuitive actually. Most of this what we are doing here is very much similar to how we do algebraic manipulations in equations. Like we add something on the other side, we subtract something on this side, we multiply with something, we divide by something. This is pretty much similar to that only. Okay. The only thing is that you should be able to visualize it. So here we are giving hg2 because look at this path, h into g2 is there, so we are compensating with hg2 instead of just h. And there is no change in this feedback. We have our C of S, we have our R of S. Now it is a very simple problem actually, nothing much complicated, and the final transfer function is g1 plus g2 into g3 1 plus g1 g3h. So try this and see how you arrive at this particular solution. Okay. Now one more question, the last one for our block diagram that I will be solving, and after this I will be giving you some homeworks, okay, that I will give in the classroom. Okay, I will be putting it as part of the notes that I will be giving. Okay, so the question is, find ys by rs when n of s equal to 0, ys by ns when r of s equal to 0, and ys by es. Where is es? This is e of s when n of s equal to 0. Okay, so the first and the last ones you can do because you have seen how to do multi-input multi-output systems. This is the one that is a little bit tricky. Okay, so before that let's see how we can simplify this, because we have a little bit of complication in this area, particular area. Okay, so I'll redraw. What I'll do is I'll bring this summing point over to here, so that we'll have two different feedbacks. Okay, that is I'm doing only for okay, let me mention that I'm doing only for this yfs by r of s at n of s equal to 0. Okay, yfs, okay, n of s equal to 0. Now when r of s equal to 0, this is not a problem because this branch won't exist. Okay, the problem becomes very simple. Now what I'm going to do is I'm going to shift this one to here. Okay, let me redraw it. So the difference in this particular problem that you from what you have seen before is twofold. The first one is, you till now you have been dealing with G and H and all. Now here you are actually using proper algebraic transfer functions. So we have a 0.5s here. Okay, and we have one more block here. Okay, the one that we changed now. This will be minus, this will always be minus. This one is coming here. Now what will this be? Because we are earlier the loop was like this and s plus 2 was here. Now the loop is like this and s plus 2 is gone. So we have to multiply with s plus 2. Okay, so this is the simplified form, and this is r of s. Now you have to solve for this what do you say, y by r. Yeah, it is quite simple actually, and the solution y by r of s is equal to s plus 4 into 10 divided by s squared plus 16s plus 20. See how you can arrive at that particular conclusion. Okay. Now, for y of s by e of s, what do you do at n of s equal to 0? Actually, now you have solved something. You have found the complete transfer function when n of s equal to 0. Okay. You can let's say derive this from whatever solution you have here, right? So, what is E? What is E of S? What is E of S? E of S is basically, right, E of S is, it is whatever is coming here, that is R minus Y is coming here. If there was some feedback, it would have been multiplied. So basically you can write E is equal to R of S minus Y of S. Okay. Now just you already have Y by R. Okay. You can substitute this, what this gives, R equal to E plus Y. You can put it here. So this is equal to Y by E plus Y, and you can just give this a dummy value as, let's call it A. Okay. Now you can manipulate, move these things around here and here, and finally you can arrive at Y by E. Okay, so basically you can find Y by E as a function of Y by R. That is the idea. Okay. So see how you can make it, and this one, these two are I'm giving as homework. Okay, I marked in the notes also. So this, you use this method, what I have shown here, and for this one you have to redo this. You have to make R equal to 0 and find the new path, and you have to redraw the diagram. That you can do because you have done something similar to that earlier. Okay, so that is up with block diagrams. I will be giving some more homework, right? Okay, so if we go back, so whatever we have done here, we have reduced, we have used different techniques of shifting, summing points, all those things to arrive at these three. That is basically whatever we have to identify where we can use this cascading, parallel and feedback, and reduce whatever we have. We have been reducing all these into different feedbacks. Okay, so here we shifted it. Okay, here we because there was a clash between this feedback and this parallel, we shifted the takeoff point. Here what was happening, here there was a clash between this forward path and this feedback, so we shifted this to here. So if you see, and then we encountered the problem of a multi-input, multi-output system. So when we are considering one one input, we made the other input as 0, and we restructured the block diagram as such, how we require it. Okay. Then this was a different type of problem, in the sense we had to interchange this summing and takeoff point, and we had to add a new summing point. Then we had to remove that summing point by taking new paths. And finally, multi-input single output system. So that is it regarding block diagram. I'll be posting some homeworks in your classroom, and after that we will start with signal flow graphs. Okay, thank you.